Hello guys, I am Akash. Welcome to Mechanical Verse. This is my second lecture of Thermodynamics. So today we will study the second part of Thermodynamics. So let's start. In previous class we have studied what is extensive and intensive properties, the two properties of thermodynamics. So let's see how intensive properties comes. So intensive properties, like intensive is equal to the ratio of extensive property 1 by extensive property 2. Okay, extensive property 1 by extensive property 2. Like the ratio of two extensive property gives intensive property. Like specific volume. Specific volume is an example of intensive property. So how specific volume comes? So how do we how do we know the value of intensive property? Okay, so intensive property, suppose specific volume specific volume is equal to specific volume is equal to volume by mass. Volume by mass. These two are extensive property. Okay, this is extensive property. Suppose this is extensive property 1 and this is extensive property 2. So this gives the value of specific volume, which is intensive. Okay, I hope you understood. So there are some examples of intensive properties, like specific enthalpy, specific enthalpy, okay, and then specific entropy. These are all intensive properties. Okay, you have to understand that intensive properties are dependent on extensive properties. Okay, the ratios of intensive extensive properties give ratio of extensive property gives intensive property. Okay, so my pattern of teaching is I teach the one thing twice. Okay, so that the thing I'm teaching you will go to your in your deeper mind. Okay, that will go to your deeper mind. Otherwise, if I teach you this thing like intensive property, this thing, it will be in your surface mind and you will forget that very easily. So if you really want to crack any competitive exams, then you have to remember everything very deeply and very brightly. Then only you can crack an competitive exam. So let's study again. So intensive property means extensive property 1 by extensive property 2. Okay, extensive property 1 and extensive property 2. if I talk about work and heat, so work and heat are not properties. Okay, work and heat are not properties. Work and heat are not properties. So then what is work and heat? So what is this? Work and heat is a path function. Okay, work and heat is a path function. Work and heat is a path function, so that's why it is not a property. But property is a point function. But property is a point function. The property is a point function. That's why the work and heat is not a property, because work and heat is a path function and the property is a point function. So here the difference comes, and that's why the work and heat is not a property. Okay, I hope you understood. So let's go to the process. Okay, what is thermodynamic process? So let's see this. Okay, so let's see this. Okay, what is process? Process means thermodynamic. Okay. Okay, process. What is process? Path through which changing state of system takes place. Suppose this is the point A. This is the point A, and this is point B. Point A means state 1 and point B means state 2. So suppose this is the path 1, path A. So the path through which the changing state of system takes place is called process. So from, suppose a substance in this point A, and suppose a substance in this point B. Okay, suppose this is one substance and this is a substance B. Okay, the process, suppose this substance is changing from, suppose I'm taking the point A, or the substance A is like, is it what is a square and this is triangle. So the substance, when the substance is in the point A, it is a square, and when this substance is going to point B, it's becoming a triangle. So there is something changing. There is something changing occurs in this path. There's something change is occurring in this path. So the change, which is called the change in this process is called as the change from square to triangle is called a process. Okay, from point A to point B. So if it goes like this is a point B, if it follows this path, so the path B and this is path B, the change in state occurs. Doesn't matter, it will change it will the whole thing will remain same no matter what path this change follows. Okay, the whole thing will remain same. So the change of the equation, that denotes this changing is called integration dp is equal to delta p is equal to p2 minus p1. This point 1 and this point 2. Okay, this is point 2 and this is point 1. This changing occurs. Suppose I am taking this for for pressure. If this for temperature, then this will like dt is equal to delta t is equal to t2 is equal to t2 minus t1. This is how the process changes. And the state is changing. Like if this is in like the substance is changing from this. Suppose this substance is in solid state. Suppose this substance is in solid state, and this thing is changing in liquid state. Okay. If I put, suppose this is ice. Suppose this is ice and the ice is melting to water. Ice is melting to water. Okay. Suppose the temperature of ice is 0 degrees Celsius and the temperature of water is let's say 40 degrees Celsius. Okay. When we put heat in this, when we put heat in this, then something the phase changing occurs. Like ice, suppose the first phase is ice and the second phase is water. The phase changes occur because we are putting heat into ice. So the process which through the ice is changing to water, the process which through the ice is changing to water when we put heat into ice, that process is called thermodynamic process. Okay, suppose this is a path A which is following path A which is following. If this process follows the path B, then the same thing will occur, that the ice will change into water if this follows the path B or the path A. The whole thing will remain same, but they are following the different paths. It doesn't matter which path they are following. It may be path A, path C, path D, anything. The whole thing will remain same, and the whole equation will remain same. Okay? So the work done during this process, the equation of work done will be W is equal to integration of, suppose this is state 1 and state 2. So state 1 is suppose state 1 and this is state 2. When it goes to like state 2 and state 1, and delta W, that means delta W means W2 minus W1. So the work done, the formula of work done means the final work done minus the initial work done. That suppose when we are putting heat into the ice, the work done which is occurred in this ice in the first initial state, and when it goes to the final state, the work which is occurring, the work which lasts in the final state, the difference of these two works gives the value of work done. Okay, suppose this is the work 1 and this is W2. So the work which is occurring in the first state and the work which is occurring in the final state, their difference will give the value of work done. So this is the formula of work done of thermodynamic process. Okay, I hope you understood. So let's do it again. Let's do it again. Let's do it again. Suppose we are studying what? Thermodynamic process. This is substance water. This is substance water, and this is substance ice. I'm taking the reverse case in this in the second part. Suppose this is water and this is, if we cool the water or extract some heat from this water, okay, extracting heat from this water, and then the work which is occurring in the first state, this is state 1, this is state 1, this is state 2, the work which is occurring in this process is work 1 and this is work 2, okay, work 1 and work 2. So the work which is occurring in the first state and the work which is occurring in the final state, the difference will give the work done. Their difference will give the work done. That means integration of final state and initial state will give the work done. W2 minus W1. This is the formula of work done. Work done. Okay? The formula of work done. And also this goes for temperature. Okay? Temperature. Also this goes for temperature, like final temperature minus final temperature and initial temperature. Integration of final temperature and initial temperature will give the actual temperature of this thermodynamic process. Okay, T2 minus T1. And same this goes for pressure. The pressure 1 minus pressure 2, pressure 2 minus pressure 1. Pressure, integration of final pressure, initial pressure will give the actual pressure of this whole thermodynamic process. And also I say that this is part A, part B, part B, this is path A, path B. No matter which path this process follows, the whole thing will remain same. The whole thing will remain same. No change will occur in this process. Okay. So this is the thing. I hope you understood. And also I want to say that the work 2 not equals to work 2 and work 1 is not equals to this will not remain same. value of work 1 and work 2 will not same, beat any condition. Okay, then go to the next part, which is the steady flow process. Steady flow process. What is steady flow process? Steady flow process. Steady flow process. Steady flow process. What is steady flow process? Okay. Steady flow process is especially means steady means property which changes with time. Property changes with time. Okay, property changes with time. And the flow process means open system. Flow process means open system. So the whole thing means the property which changes with time in open system is called steady flow process. So what is steady flow process? The property which changes with time in open system is called steady flow process. Okay, so what are the examples of steady flow process? Suppose isothermal process. Isothermal process. In isothermal process, iso means, what is the meaning of iso? What is the meaning of iso? Anyone knows? Okay. So iso means the property. Which remains constant. Iso means the property which remains constant throughout the process. Iso means the property which remains constant throughout the process. What is iso? Iso means the property which remains constant throughout the process. Suppose isothermal. Thermal means what? What is the meaning of thermal? What is the thermal word is denoting? Thermal means temperature. Thermal means temperature. Okay, thermal means temperature. That means the temperature is constant. But isothermal, in isothermal process, temperature is constant, but pressure is not constant. Volume is not constant, but the temperature is constant. So the isothermal process denoting that the temperature will remain constant, but the other properties will not remain constant. Okay, so this is more specified. This word is more specified in this process. Like temperature will remain constant, but pressure and volume will not remain constant. Is the process. Suppose if I talk about isobaric process. Isobaric process. So isobaric process means constant pressure. constant pressure. That means in isobaric process the pressure will remain constant but the temperature and volume will not remain constant. Okay, this is the second kind of process in thermodynamic processes. Okay, this second kind of process the pressure will remain constant, means P will constant but temperature, volume, temperature and volume will not be constant. Okay, this is the isobaric process. So let's go to the third process of thermodynamic processes, is isochoric process. Okay, I hope you are guessing that what is isochoric process. Okay, so let's see. This is very simple. You know, the most simple or most easy part of mechanical engineering is thermal engineering, and the most interesting also, because you will see the lot of applications in our daily life of thermodynamics. Okay, without thermodynamics our universe or life is here. So thermodynamics is very important and very interesting topic in whole mechanical engineering, or you can see in whole science. Okay, so you really have to understand well and know well this topic, thermodynamics. Okay, so let's go to isobaric process. What is isobaric process? Iso means, you know, constant, and what is choric? I hope you are guessing. Okay, isobaric means what? Choric means volume. Okay, that means volume will constant but pressure, temperature will not be constant, only volume will constant. So these are the three processes of thermodynamic. These are the three processes of thermodynamic processes. Okay, so note it down. Okay, I hope you understood what is a steady flow, what is the steady flow process. These are some examples of steady flow process. Okay, some examples of steady flow process which occurs in the processes which occurs in the properties which changes with time in open system is called steady flow processes. Okay, so which are the properties? Suppose in isothermal processes, which properties are changing with time? Pressure and volume are changing with time. Okay, in isothermal process, pressure and volume are changing with time. In isobaric process, the pressure and temperature is changing with time. In isobaric process, volume and temperature is changing with time. Okay, so let's note it down. Thermodynamic processes. First, isothermal. Second, isobaric, and the last one is the isochoric. Okay, temperature constant in this process, temperature constant, pressure constant, volume constant. Okay, pressure constant, temperature constant in isothermal, temperature constant, isobaric, pressure constant, and in isochoric, volume constant. Okay, so let's go to and the one thing is unsteady flow process. Unsteady flow process is the reverse of steady flow process. That means In unsteady flow process, the properties, those properties which changes with time, this called unsteady flow process. This is, the steady flow process is reverse is unsteady flow process. Okay, so I'm not going to that part. I'm going directly to the systems. I'm going directly to the systems. Achha, I think I have already taught you the three systems of thermodynamics, like open system, closed system, and isolated system. Okay, I hope you understood. Okay, if you don't, then I will make another video of that lecture. Okay, so please let me know in this comment section, then I will do it much better. I will do that lecture in a much better manner, or in a much better way. Okay, so I'm going to ideal gas equation. I'm going directly to ideal gas equation. Ideal gas equation. Ideal gas equation. Ideal gas equation. Very important. 3-star. Very important. Ideal gas equation is very important in thermodynamics. You have to know. You have to understand this equation well. Okay. This is not so difficult, but you have